two files, which is in PDF and also in M1. Only two PDF. So if you save each question separately, means you have combined together. Okay, so name your M file as this quiz one. Okay, question. So for M file, yes, you can put it your question number. So your ID quiz one underscore one underscore question, which question that you answer. Okay, no space are allowed in the file name. Okay, I saw that only two questions for quiz one, only two questions for quiz one. So which means that Q1 and Q2. Okay, submit the PDF file together with all the M file by Moodle. Okay, so make sure every M file codes that you start with 3 comment line stating question number. So you put the comment, question number, comment again, your name, Lana, and my ID. What is my ID? Okay, if you have any failure for your submission, please let me know. Okay, please let me know. Then I will and please email me. Okay, I'll be there for your in Teams all the time. So if I'm late to reply you, just ping me again. If until 5 hours I didn't reply you, okay. That's all. Are you clear about quiz one? Yeah. Okay. So now let's go to question. Practice question. PowerPoint. Okay, wait. Not sure why my PowerPoint like this. It's okay. We do the question, practice question later. Okay, let's look at chapter 2.3. We go. Okay. Okay, let's look at the practice question. Okay, so okay, you can refresh your Moodle. I have shared with you the answer for practice 2.2. Okay, open your Moodle. Okay, so plot the function exponent negative 0.5 x times sine 2x for 100 values of x between 0 and 10. Okay, use a 2-point white solid blue line for this function, then plot another one for cosine in the same x. We use 3-point dash red line for this function. Okay, so be sure to include legend, title, assist level, and click on the plot. Okay. Okay, so I have shared with you question 1. Okay, first set the value 0 until 10 for 100 values. I use linspace space. So this is my equation for first question, which is exponent negative 0.5x times sine 2 dot times x. So which means that we want our x to be, okay, because it's in array, right? Because we have 100 values. So plot x, y, 1. Okay, so we do one by one. Okay, then, okay, we use blue line with 2. Then we click on title. I put 2.2 practice question 1. Okay, as label, I put x-axis. Okay, maybe if I want to be more like more you can put I3. Okay, I think instead let's display because I want to use latex later on. Okay, y level, y axis, hold on. Okay, why I use hold on? Because, okay, we have to overlap another graph, which is the same one, which is negative 0.5 times x times cosine, okay, 2 times x. Then we have to use rate, then dash line. So rate dash line is r dash dash, line width is 3. Click on. So and after that, we use legend. This one, I did not specify where is the legend location, but you can put more if you want to put it north, is outside, is outside, or where. Okay, then we run it. Okay, you will get a graph like this. Okay, you will get a graph like this. So you see here, the red one is bolder, is more thicker line compared to the blue line. Okay, so all of the value here, okay, is here. Okay, all of the value is here. So now here, okay, the title is 2.2 practice question 1. And this one, you see the label, x-axis, y-axis, and grid on. So you see at the back, there's a grid. Do you get it? Do you get it? Do you get it? Yeah? Okay, so this is practice question 1. Okay, this is the practice question 1. You have to use hold on. Okay, you have to use hold on. Okay, next is question 2. Okay, question 2, we want to do same like question 1, but you use a log linear plot. Okay, you use a log or you use a log linear plot. Same again, same question, but you use a log linear plot. Okay, this one I leave it to you to answer it by your own. Okay, question 3. Okay, so here we have to create an array 100 input samples from 1 to 100. Okay, so we use linspace and plot the equation. Okay, the equation is fx, okay, y is equal to 20 log to x base 10. Okay, so we have to use a semi-log x plot. Okay, so we want a solid blue line with 2. Okay, then label each point with a red circle. Okay, this one also you have to use hold on function. Marker. Okay, and first we have to draw the graph, then after that we have to draw a marker with a red circle. Okay, I have shared with you the answer. Okay, so first of all, this is question 3. Okay, so we create 100 value from 1 to 100. So 20 times log 10, 2 times x1. Then we open a window figure. Semi-log x, x1, y1. Okay, blue, B is blue, line with 2. Okay, this one, Okay, this is for the first part. Okay, this is for the first part. So which means that you will get this graph. Okay, this is the first part that where you get this graph without a marker. Okay, without a marker. So you see here on x-axis, okay, is a log in a log range. Okay, it is in a log. It's in a log format. Okay, in x range. That's why we use semi-log x. Okay, now our part is we have to do a marker for each point. Okay, a marker for each point. So we use hold on. So again, we use the same function, same function, but instead of x1, we create x2, y2. And this time around, we only create a marker, okay, red color, and I put size 5. Okay, and this one I use circle. So this one, okay, this is circle. Okay, this is circle, red color. So you see here, I have created, okay, a value, a marker that overlap with the graph. Okay, that overlap with the graph. Okay, so some of my students ask me that if let's say we don't do the marker and we don't do the graph, but we only write the marker only. We only want to plot the marker. Okay, it's the same code. Okay, but this one, you just let's say you just want the marker. Okay, you will get like this. Okay, but here I want to plot the marker in the graph. Okay, that's why I use hold on function. After I finish marker and graph, then I use hold on. Okay. Next is question 4. Okay, this one some of students approach me. Plot a graph of fx 5 times log 2x base 3 with suitable domain. Okay, in MATLAB, we only have natural log. I forgot to mention before. We only have natural log, log base 10, and log base 2. So this one is log base 3, right? Okay, log base 3. So you have to convert. This one you need a bit of mathematical theory. Okay, how to convert log base 3? Okay, so you have to convert into log base 10 or into natural log base. Okay, you have to convert log base 3 to log base 10 or log with the natural base. Okay, so do you remember how to do it? Google it. Okay, so this is what, okay, this is the formula, right? Okay, log base log A base B. If you want to change the log is log the new base A over log with the new base O B. Okay, so here we're going to do the same thing. Okay, we're going to do the same thing, which is okay. So here we create 100 value. Okay, between 1 to 100. Okay, so here we want to change from log base 3 to log base 10. Okay, so it is okay, so it is wait, hold on, I have to use a marker. Okay, it is fx 5 log 3 base 3 to x. So I have to convert it. So it will be 5 log 10 times x over log 10, log 3 base 10. Okay, so this one you need a bit of mathematical knowledge. Okay, so we convert it. Then y1 is 5 dot multiply y. Okay, because we have many x. Okay, so that's why we use this one dot star dot star. Okay, figure plot xy 1 1. Okay, then label x-axis, y-axis, put the title. Okay, so you will get like this. Okay, this is without the marker. Let's say, okay, you want to put a marker. Of course, you have to put hold on, then repeat again the question. Okay, set a new variable x2, y2, then plot x2, y2, specify your marker, what shape you want to be, what color you want to be, then you will put a marker all over the line. Okay, you can put a marker all over the line. You understand? You get it? Okay. And this is a practice question 4. Okay. I know last time I showed you how to do tangent graph. Actually, okay, we can have a shortcut way to do a tangent graph to answer question 5. Okay, plot the graph of this one tan tangent to x, or x is between negative 2 pi until positive 2 pi. Okay, so this is okay. I found a shorter way to do it. No, I suggest a shorter way to do it. So which is f is equal to, okay, you put a function here, alias x, okay, tan 2 times x. Okay, so what is our x? It is f is equal to, our x value is between negative 2 pi until 2 pi. Pops off, then I put it as click on. Okay, it will automatically create a tangent graph. Okay, it's automatically create a tangent graph for you rather than the previous coding that I show you. Easier, right? This, okay, this one is easier. You don't need to do looping. Okay, okay, but this one is in yeah. Okay, for question 6. Okay, for question 6, we do cosine, absolute cosine x. Okay, you will use the same like this. You use the same function like this, but instead of it, we use absolute, and also this one is tan. This one is tan. We use cosine, then add absolute function in your question. Okay, so this one is x is between negative 2 pi to 2 pi. Okay, absolute cosine x. Okay, absolute cosine x. Okay, so this one is, I put here absolute cosine x figure. So I use f plot. Okay, which is f is the function of f, which is absolute cosine x, negative 2 pi until 2 pi, pops off, click on. But here I didn't put any title. You can add title for you. Okay, you can add title by yourself. Okay, you can add title by yourself. Okay, and this one doesn't have any arrow. You can add your own arrow. You understand? Yeah. Okay. Okay. Last question. I have shown you, right? I have shown you. Okay. Again, this one I have to put 2 plus 0 times x because MATLAB cannot understand which is y2 is equal to 2. Okay, so you will get this line. Okay, but this one is I use whatever MATLAB decide for me. So blue line, and the width is only size 1. Okay, so this is the answer for question 5. Okay, we have shared it before. Okay, 2.2. Any question? Any question? Okay, next we're going to get more complex, which is we combine log and exponential, quadratic and linear, quadratic and other things, okay, in the same graph. Okay, in the same graph. Okay, please open 2.3 slide. Oh, no, you just focus on mine. Okay, so piecewise function. Okay, this I know that there's a shorter way to use toolbox, but in this course you are not allowed to use toolbox. Okay, you are not allowed to use toolbox. Okay, so we will do manually for all of this. Okay, piecewise function is also used to describe the property of any equation or function. It represents various conditions in function or equation. Okay, so there's several ways to plot piecewise function without using symbolic math toolbox. Okay, I go for the first one, plot as independent function. This one is more complex. Okay, this plot as independent function. I think this one is easier. And second is use loop, if else statement. Of course, there's a pro and con for plot as independent and use loop. If it's, your equation is very complex, you use loop. If it is just a simple thing, use plot as independent function. Okay, I'm going to show you, okay, the first part, which is plot as independent function. Okay, so plot as independent function. Okay, so the first one. Okay, so the first one is define the domain. Okay, so we have this function. This is piecewise. Okay, if you're not mathematics student or not, I think all of you already know that this is you learn in high school. This is a piecewise function where your x is between -2 to 0. This one is 0 to 2, that's 2 until 4. Every x has different function. Okay, so which means that you have to create, this one we have 3 conditions, so we have to create x1, x2, x3, and the output as y1, y2, y3. Okay, with the respective domain. What is the respective domain? x1, x2, x3. Okay, plot them with the line of same properties and mark the endpoint. Okay, plot them with the line and mark the endpoint. So because you see here, okay, we have equality and inequality sign, right? So we have this. Okay, so I like sketch the graph. Okay, -2, 2, and 4. Okay, so I know that x squared, okay, x squared from -2 to 0.